Alright, so the back of your review sheet, for the first circle here you do need a label. So if PR, first of all, QS and PR are perpendicular. So if that's true, you know that this is congruent to this. And therefore if RP or PR is 8, I know that this is 4 and this is 4. So if that's 4 and that's 4 and QT is 3, then I'm going to have to use the Pythagorean theorem, which is the square root of 3 squared plus 4 squared, to find the radius, which is going to give you 5. So my radius is 5, and therefore QS is also equal to 5. Now in the next one, I know that QS is 13. So that gives me the radius. QS is a radius, so that means this is 13 and this is 13. This is still a 90-degree angle, but now QT is 5. So how am I going to find PT? I have to use Pythagorean theorem. So this case now it's going to be 5 squared plus x squared, and this time I have the radius, so that's 13 squared. So this is how I'm going to solve it. It's going to be x equal to the square root of 13 squared minus 5 squared, which is equal to 12. So that means PT equals 12. And finally, for the last one, I know, again, the 90-degree angle right here, because they're perpendicular. And PR is 12, which means that this is 6 and this is 6. QS now is 10, which means this is 10 and this is 10. And I'm going to use Pythagorean theorem to find the QT. So, again, 10 is your hypotenuse, so that's what's going to be C. 10 squared equals 6 squared plus x squared. And x is going to equal the square root of 10 squared minus 6 squared. 10 squared minus 6 squared. So therefore that's 100 minus 36, which is the square root of 64, which is 8. So QT equals 8. Alright, so QS is 5, PT is 12, and QT is 8. Moving on, looking at these, the following segments that look tangent to the circles are tangent. So therefore, this looks tangent and this looks tangent, which means they are tangent. So if I want to look at this segment, I know from that tangent segment theorem that this segment equals this segment. So I'm just going to set up my equation. 40 equals 3x plus 4, and solve this equation. So minus 4, 36 equals 3x, divide by 3, and x equals 12. This one over here, again, this is a tangent. That means that this is a 90-degree angle and you have a right triangle. So therefore you have to solve. Again, this is your hypotenuse, so that's going to be x plus 8 squared equals x squared plus 12 squared. Now to solve this I have to FOIL. So it's going to be x plus 8 times x plus 8 equals x squared plus 144. So therefore when I FOIL, that's going to be x squared plus 8x plus 8x plus 64 equals x squared plus 144. And now I need to combine like terms. If you notice, if I subtract x squared from both sides, they end up canceling out. So therefore I'm just left with 16x plus 64 equals 144, which is a two-step equation. So if you subtract 64 and then divide by 16, which is just a two-step equation, you get that x equals 5. Okay, and that's again from just solving this equation right here. All right, last two problems. All right, so A is tangent, E is tangent, and C is tangent. All of these are tangents. So what do you know about 4 and this segment? This segment and this segment are congruent, so this is 4. You also know that this is 3 and this is 3. So what is this whole segment? 3 plus 4, x equals 7. And the last one, again, this is a right angle because A is tangent to the circle, and 8 is your hypotenuse, so 8 squared equals 4 squared plus x squared. Solving this equation gives you 64 minus 16 for x squared. 64 minus 16 is 48. So taking the square root of 48 on both sides and simplifying the radical. So x equals the square root of 48, and now you have to determine simplifying the radical. So a perfect square factor of 48 is 16, which gives you 16 times 3. The square root of 16 is 4, so 4 root 3 is your value for x. Alright, if you have any questions, please see your geometry teacher or one of the other ones.